Scientific discoveries significantly improve our lives, from the way we understand health and treat illness, to how we study Earth's history to learn to adapt to extreme climate events. But today, the sheer amount of scientific information is overwhelming. There are so many new breakthroughs on a daily basis that it's impossible for humans to know everything that has been discovered. Elsevier, for example, has archived more than 13 million scientific documents. That rate far exceeds our human capacity for analysis. This access to so much scientific knowledge has created information overload. Scientists are currently incapable of keeping up with all the available literature. Confronted with so many individual facts, we can miss the big picture. A Hindu parable perfectly illustrates this, the one in which a group of blind men touches an elephant. Each man is familiar with the given part he touches, the trunk or the tusk, but nobody has a sense of the whole animal. Today, this elephant is geoscience, cognitive science, chemistry, biology, in fact, all the sciences.
Our idea is conceptually simple. Use artificial intelligence, or AI, to help. We propose an AI approach for the systematic analysis of scientific discoveries. Computers will read the millions of publications available and begin to assemble the larger puzzle from the individual pieces. This approach also promotes a more objective view of the current science, reducing researcher subjectivity. We need to teach machines how to understand scientific language so they can become our research assistants. We envision that in the future, computers will read scientific texts accurately and quickly, and then will infer new knowledge from existing facts. While this is extremely challenging, we have early results that demonstrate that this is possible and that the payoff is substantial. At the University of Arizona, an interdisciplinary group have built machine reading technology that is capable of reading thousands of cancer research publications per day. Together with collaborators from Oregon Health and Science University, we demonstrate that this knowledge led to a better understanding of the cellular processes responsible for 7 different cancers. We then applied the same machine reading technology to other fields such as children's health. This requires one to understand multiple fields such as economy, biology, psychology, and environmental science, among other things. Our research shows that with the help of experts in the various specialties, our automated research assistant was able to use thousands of publications to assemble a large causal model that explains how these factors interact to impact the health of the children. And it did this in only a couple of hours. We propose that one of our most important breakthroughs in addressing information overload is this hybrid approach in which human and machine intelligence work together. This will allow us to synthesize vast areas of knowledge and to turn our volumes of data into powerful resources. It will help us answer one of the biggest challenges in science: how to accurately generalize from limited observations and data. We'll have a much better understanding of the global significance of the processes we observe and measure. In other words, we'll know if our local specific observations have global implications.
We plan to apply this hybrid AI-human approach to earth sciences in order to make advances in major fields of Earth history such as plate tectonics. This hybrid intelligence predicts the world of tomorrow by reconstructing an accurate picture of Earth's past. For example, our ability to distinguish the impact of humans on climate change relies on our ability to distill data from Earth's geological past. We know that past climate variability has transformed Earth's surface, ocean, and atmospheric circulation. But how, exactly? The hybrid AI-human intelligence system will sift through hundreds of thousands of individual geological data points. It will help us piece together the data, interpret it, and then generate an array of plausible hypotheses. This invaluable geological information will yield big results. We'll use it to gain insight into our natural resources, tackle climate change issues, and even search for and explore other habitable planets. This big idea will overcome information overload and has the potential to lead to a truly objective global understanding of scientific findings. Put simply, we will finally be able to see the whole elephant.